Hello everyone, welcome to the video. Today we'll be seeing how MIP mapping works on a single model. So if you look into the code, so this is the main.cpp of my code where I do all the changes. And if you scroll down, I'm using the box model here. I've used the same model for my assignment 3 and same model has been used here. As we go down, we load our mesh here to get the model into our screen. This is the compile shader function where I give the path to my MIP vertex shader as well as my MIP fragment shader. So this is my MIP vertex shader. And next comes the MIP fragment shader. So this is my fragment shader code. And I'm mapping them both in my compile shader function. As we scroll through, here is where I give my texture image. So here I've used simple checker.png where I'll get a checker box texture onto my model so that the MIP mapping would be easily visible on a flat surface. Next, I declared a simple mouse wheel function where it basically enables to zoom in and zoom out, and this is the key press function where I've used 1 2 3 4 to signify 4 different types of MIP mapping and basic pitch, yaw and roll key presses. So let's get into the demo. So I've built my program and this is without MIP mapping, the output. Then I press the spacebar and I get the MIP map effect. As you can see, the nearer textures are highlighted and the farther things are blurred. So we can switch between using spacebar. Next is the first type of MIP mapping, which is nearest neighbor MIP mapping. It basically chooses the nearest MIP map level based on the distance from the camera and uses nearest neighbor filtering within the selected MIP map level. So next is the bilinear MIP mapping, where it also uses the nearest MIP map level, but it uses the bilinear filtering within the selected MIP map level. The third type is the trilinear nearest filtering, where it selects two closest MIP map levels and blends them using the linear interpolation. It reduces texture popping between MIP levels, but may still look rough due to nearest neighbor sampling. And within the selected MIP level, it uses nearest neighbor filtering. The last type is called as trilinear filtering, where it selects two closest MIP levels, uses bilinear filtering on both the selected MIP levels and performs linear interpolation between them. And this type is considered to give the best quality of output out of all the 4 types of MIP mapping. So this is how we can just play around with the model by showcasing different types of MIP mapping on it. Also try to rotate the object like using the pitch, yaw and roll key presses.